Hello and welcome everyone to our Diving into Docker webinar with the fabulous Shawn Powers. My name is Karen Klinger and I'm your designated chat wrangler today. So everybody please be sure to chat in with your questions, and Shawn will do his best to answer those near the end of our time together. We are recording today's webinar, and our recording will be available later this week on our blog at blog.cbtnuggets.com. And with that glorious information, I'm going to officially hand it over to Shawn Powers. Shawn, take it away.
Okay, hello everybody. If you can hear me, raise your hand, and I won't see any of it, but everybody will be raising their hands, so that'll be cool. Today we're gonna dive into Docker. Now, when I say diving in, I really want to, very, very clever. Everybody's using the raise their hand button. I did see that, so well done. Anyway, we're going to be talking about Docker. It's an introductory thing. I want you to understand what's going on. So basically, we're going to go over these things. I'm going to explain what Docker is, what it does, why you might want to use it. I want to show Docker in action on a super cool Ubuntu machine that I have running and have Docker installed. After the demo, I'm going to reveal a secret treasure map to a pot of gold. So if you fall asleep or if you log off, you're going to miss that. So no nodding off. And then at the end, like Karen said, there should be time for some questions and answers, I hope. Times for questions, and hopefully I'll have answers to those questions. Otherwise, I can refer you to somewhere else. So Docker, if you're familiar with the concept of virtual machines, which if you decided to join the Diving into Docker webinar and you don't know what a virtual machine is, well, you're a brave person. I'm assuming everybody knows what virtual machines are. And it's kind of this awesome technology that geniuses invented a handful of years ago. And the idea was to get a giant machine like on the left here, and it would host an operating system and then host, let me get my little crayon here, and then a hypervisor would be on top of that. And then you would have all of these little enclosed virtualized hardware devices. So this is like an entire server, and you would install an OS on this, and then you would run your application inside of it. This is really, really awesome, and it was a great way to consolidate and be more efficient, to better utilize resources. But what happened is we went all out, right? We started spinning up individual servers for every little thing that we wanted to do. So like I worked at a school, and in my school environment I had a virtual system, and I would spin up, this is the web server, and this is the email server, and this is the webmail server, which is the web server and an email server. And we would just start filling our virtual host machines with all of these various computers, because these are like entire computers, and then we would have to maintain them. So it really kind of shot us in the foot. Something that was supposed to be more efficient, all of a sudden now we have like 4 OSs to maintain and 4 hardware devices to maintain. So Docker takes that concept of virtualization and pares it right down to an application. So rather than virtualizing the entire hardware device, we are just virtualizing the environment that a single application runs inside. And that makes for super efficient computing, because there are no operating systems installed. The apps are running on the base operating system that this host machine. So we just have this one single operating system running. In our case, it's going to be Ubuntu today, and it's running this system. All of these apps are running on Linux, and it's on the same operating system. Now they do have their own environment, and I'm going to talk about that a little bit next. But what's really cool is we stack these super close together. There's no extra operating systems to maintain. So you have system patches on just this single operating system, not on all these operating systems over here, which really didn't save us any time in the long run at all. So Docker is a way to more efficiently use what you have and save you time, because we just don't have a ton of time. Now, how does it go about doing that? Well, I'm glad you asked, because my next slide is another super cool drawing, and this talks about what Docker actually does. Now, Docker starts with a Docker file, and this is basically just a recipe or a script or a bunch of directions for how to create an entire environment for a single application. And that whole environment is called an image. So we create an image based on this Docker file. Now, a really cool thing is that most images that you're going to use are already created and they're on the internet. We're going to talk about that in a minute. But if you want to create your own, you do that with the Docker file. The Docker file says, what dependencies am I going to need inside my image? Like, do I need PHP, Nginx, Java? And then you can actually add your own specific application, and it loads it inside of this image. And this image is kind of just an awesome, pristine environment with your application that's never actually executed. What Docker does is it takes a copy of that. It copies it byte for byte, boom, brings it down here and creates a container. So a container is a copy of this image, and the container is actually what executes down here. This is where your application actually runs. The cool part about that is, let's say you have a web server app that you need to scale. Well, you can take this same image and spawn off multiple containers that are mirror images of this, and so you can scale really, really easily without the need to spin up another entire virtual machine like you have to do in the virtualized world. And so today what we're going to do is I want to give you a demo in two flavors, if you will. I'm going to start with a base image. Now, remember I said an image contains the dependencies or the environment that the application will run in. Well, what we're going to do is we're going to use a pre-made CentOS environment. And that's a CentOS image. Now you're probably thinking, Shawn, you silly guy, you actually said we're going to be using Ubuntu today. Well, we are. The coolest part about Docker is that you can actually have a CentOS environment running inside Docker on an Ubuntu machine. So it doesn't matter if you have an application that must run on CentOS or Red Hat Enterprise Linux. Great. Spin up an image that has that environment and allow it to run in a Docker container on whatever Linux distribution you have running your Docker daemon. It's really flexible, and it allows for multiple images or multiple applications that normally wouldn't be able to run right next to each other. They run next to each other and they work really, really well. It's really slick. So anyway, first we're going to start out, we're going to spin up a CentOS image and run a single application, and then I want to show you a pre-built image where the application is built in. Along the way we're going to learn some Docker commands as well. So let's get out of this little image. I'm going to try to share my screen, so if you see, hopefully you'll see the correct thing I'm trying to share. If you see like a Star Trek video playing, I apologize, but hopefully I get the right screen. Okay, I think right now you should be seeing my Ubuntu box here, and I lost my chat window. So if you're not seeing it, do the little raise hand button, because then I'll fix it. But if I don't see any raised hands, I'm going to assume that you're seeing this correctly. Now, trying to make sure I had enough time to go through everything, I already installed Docker on this system. So the system that you see here is Xubuntu. It's 14.04.2. It's the long-term support version of Ubuntu or Xubuntu, and it already has the most recent version of Docker installed on it. If I tried to show you how to install Docker, it would take too long in the webinar. So Docker is already installed, and I want to show you our first command. You might want to take notes, or this is going to be recorded so you can look at it later. But always type sudo if you're using Docker. Now you may have an installation of Docker that doesn't force you to use sudo or an elevated privilege, but by default it's going to need to have root access because you're spinning up entire environments, including environments that need network access. So we're going to use sudo every time. So sudo Docker, the first command I'm going to type is images. And what this is going to do, let me type in my password, is it's going to show us any images that are local on our machine. Now here we have a CentOS image, and this is a base image. This is the entire environment for applications to run in a CentOS environment. Now, I got this CentOS image from a place called Docker Hub. The cool part about Docker Hub, yes, you can go to the Docker Hub website and browse around, but the Docker command line tool has a great way for us to search as well. So I'm going to say sudo docker search well, let's say Ubuntu, and we're going to get a huge list of Ubuntu images that are available on Docker Hub. And we can actually download this official Ubuntu image, and we can have an Ubuntu environment if we want to run our applications in Ubuntu. Again, this operating system that we're on is going to be Ubuntu no matter what, but this is just what environment our applications are going to run in. I just wanted to show you that there's a ton out there available, and you can use that search command to find it. But today we're going to use CentOS, and that's going to be our base image. Now remember I said that images and containers are different. Images are like that pristine thing that you make a copy of, create a container, and the container does all of the dirty work. So we typed sudo docker images to see our images, but if you want to see what's actually running, you type sudo docker ps. If you're a Linux person, ps probably looks familiar. So sudo docker ps, and you're going to see right here, container ID image, I have nothing running. So let's change that. We are going to, in the next minute, actually spin up and Dockerize our own application. So it's really easy to do. Yeah, follow along with what I'm typing because it's a little complex. I'm just starting with the base image. So sudo docker run -d is going to say I want it to run an image as a container. -d means daemon, so in the background. So it actually just runs in the background and does its own thing. And then what image? I want to use CentOS. Now if CentOS wasn't already downloaded, it would pull it from Docker Hub, which is kind of a cool thing. It would pull it automatically, but it's already on my system, so we don't have to wait for it to download. And now in that image, if I just started it, would just be an environment sitting there doing nothing. But I want it to actually run something. And so now I can type on the command line what I want to run inside that CentOS image. Here I'm going to type bin -c. What I'm going to type here is just a very simple bash script. If you're a Linux person, it should look pretty clear what I'm doing. Bear with me while I type this. I should have copy and pasted, but I didn't. We should hum some music. Okay, so this is all typed out. What's going to happen is inside our CentOS container, it's going to be doing while true do this loop. And all this loop does is count from 1 to infinity. It just 1, 2, 3, 4. So that's my entire application that we're Dockerizing right now. So if I press enter, it's going to give me this long string, which is actually the container ID number. You have to memorize this number right now. There's going to be a quiz at the end. No, of course, I'm just kidding. If we type sudo docker ps, remember that ps command will show us running containers. It'll show us exactly what's running. So this is the container ID, kind of truncated. The image that is running is CentOS, and the command that's running inside that CentOS environment is this bash while loop. Not truncated, it didn't show the whole thing, but this is what's running. Okay, it says when it was created. The thing I want you to show now, WordWrap makes this a little bit hard to read, but every time you spin up a container, it creates a random name. It's usually a silly name. So this names column, this is the name of our running container. So when we want to manipulate that container, that is the name that we refer to it as. Okay, so it's running in the background. Now I just hit enter. What the heck? It's running. I did that -d, so it's running in the background. If you want to see what it's doing, you can type sudo docker logs, and it'll show us the logs for whatever container we specify, and that container we're going to specify is mad Carson. Now if you're doing this at home, your name is going to be different. It does a random name every single time. So sudo docker logs mad Carson, hit enter, and it's going to show us this is the log. This is what it's been doing. It's been counting. It counted to 75 in the amount of time that I was yammering on. If I push the up arrow and do the docker logs mad Carson again, we'll see, oh, now it's counted all the way up to 86. So it's running in the background on our computer just like a daemon. However, the cool part is, and you can't really tell from this example, but it's actually running in a CentOS environment. So if I had a command, and I couldn't think of a command that would do this, but if I had a command that said, what kind of system are you running on? And it would respond over and over, CentOS, CentOS. That's what would happen here. If you have an app that only runs in CentOS, it would run here because that's the environment that it's inside. All right, so let's see how high it counted. It's to 117. Now another command I can do is sudo docker stop mad Carson. And oddly enough, it does sometimes take a minute for it to stop. But what it's doing is it's stopping all the commands inside, and it's kind of halting the container that's running. Okay, there, it gave us the name back, so it's running. If I do sudo docker ps, boom, it's not running. Now here's a trick for you. If you do sudo docker ps -a, it actually shows us things that actually aren't even running. So -a will show you all, those that are running and those that aren't. So here you see, okay, Mad Carson is now stopped. It's not running, but it's still existing. So if we look at the logs, I just pushed the up arrow to get back, but if we do sudo docker logs Mad Carson, we'll see it counted up to 134 before I stopped it. But if we look at the logs again, it's still 134 because it's no longer running. All right, it's stopped and it's kind of just in a state of I'm not running, I'm just sitting there. If we start it over, and we would do that with the start command, but I'm actually not going to do the start command because you should be able to figure out what happens. It will start again, and it will start at 1, 2, 3, 4, and count all the way up to however high we leave it. Now, one of the problems with Docker is that sometimes you end up making a mess when you keep spinning up containers. So I want to show you how to clean your room here. Sudo docker ps -a shows us all of the existing containers, whether they're stopped or not. So we can type sudo docker rm mad Carson. And now if we do sudo docker ps -a, we'll see it's no longer running. Now if we do sudo docker images, we can see we still have the CentOS image, because remember that never executes. That's just there for us to make a copy and put that live image into existence, create a container out of it, and then make it run there. Although this is a very valid way that we have Dockerized an application, that's not generally how you go about things with Docker. Generally, your image actually contains an environment like CentOS plus your actual application and startup scripts and everything like that. So if you're starting a web server, for example, you're going to use an image or build an image that when you start it, it will automatically run without the need to like type in what commands you want to have. And I have a great example of that. Let me find my back arrow here. Okay, hopefully you're seeing this back at my image here. But there's this awesome test image. And this is just somebody created a simple web server running on port 8080, and it's just a great example of how things work inside of Docker. So if you want to write this down, it's awesome. I use this a lot when I'm testing network stuff, ADEJONGE/hello world, and what it does is it runs a web server on port 8080. So what I'm going to do is install this. I'm going to actually I'm going to download this from Docker Hub, and it's going to spin up and start a web server, and we can see exactly what's going on. Share applications. Okay, here we are back. Hopefully you're seeing this again. Now, here we can type sudo docker. Now, we could type the pull command and say ADEJONGE hello world. And what it would do is it would pull that image from Docker Hub and store it right next to CentOS. But there's a shortcut. We can actually just say docker run -d for in the background, ADEJONGE hello world, and this is it. So we do this and press enter. And it's going to say, dude, you don't have that image. It says right here, unable to find the image. You don't have that. However, it's smart enough that it's going to go out to Docker Hub and download that image for us, create an image so it's stored on our server now, and spin up a container using that image. So if we type sudo docker images, we're going to see that we now have that stored locally. But if we type sudo docker ps, we'll see that we have the Hello World app running. It's called Hungry Cray, and it's now running on our system. So it's running a web server on port 8080. The problem is we have absolutely no idea what the IP address is of this machine, because Docker by default will create an IP address on the fly, and there's some advanced networking stuff that we're not going to get into today in the webinar, but it creates on the fly this private IP address, and you can access it if you know that IP address, but it doesn't tell you by default. So what we need to do is type sudo docker inspect hungry_cray. Again, this is just the random name. Yours will be different. Press enter, and we're going to get a long string of information. Everything you've ever wanted to know about this running container, right? So what I'm going to do is type that command, but then I'm going to pipe it through grep IP. What this is going to do is it's going to show us all that same information, but it's only going to show us the lines that have the letters IP in them. So we do that, and it's filtered out, and here we have IP address 172.17.0.4. Okay, so what we can do is open up a web browser, go to http //172 dot, oh, what was it? I already forgot. 17, okay. Dot 17.0.4 colon 8080, because remember it runs that web server on port 8080. And now the moment of truth. Did my demo work? Sure enough, this is it. This is the response I expected. I hope you weren't hoping for a really fancy page. It says, hello world from the minimal Docker container. So it's working. It's actually spun up the container. The container is running this tiny web server on port 8080 on this IP address. It's really awesome. We can access it, and we can also, let's see. So what if we did the same thing again? I just hit up arrow again. So now I'm going to spin up another image. Sudo docker ps. And now we have one called Hungry Cray. That's the original one, still running. And now Reverend Jones. Okay, well, let's do that whole inspect thing. Sudo docker inspect Reverend, my typing skills, Jones, grep IP. Now this one has an IP address. Oh, it incremented. Big surprise there, right? I mean, that's not too much different. But if we go over to Firefox and we switch this from 4 to 5, we get, well, the same exact thing. But it didn't give us an error, right? There's no error because it's actually running and it did its thing. So it's running on 4 and 5. So if we go back, it's running here. We can hit refresh. Boom, boom. Yep, that's working. And if we go to 0.5, that one is running too. And that allows us to run multiple apps on the same port because they each get their own fancy IP address. It's kind of a cool thing that Docker does. You have lots of networking options, but by default it'll do that. So now we have all those things running. Let's get rid of them, right? Sudo docker. Now if I were to just say rm, it would, well, let's do that. Hungry Cray. It's going to say, dude, Hungry Cray is running. You can't do that. So we could either stop it and then delete it, or in one fell swoop we could go sudo docker rm-f, a lot like a Linux command, Hungry Cray. Boom, it stopped it and deleted it. Now if we do ps, we'll see we just have Reverend Jones running. So sudo docker rm-f Reverend Jones. Now it's deleted that, and if we go back over here now, since those have been not just stopped but deleted, hit refresh, it's just going to hang and hang and hang and hang. See, it's not loading. It's not there at all. It can't. Oh, there we go. Unable to connect because it's no longer running on our system at all. All right. So that is how Docker works. I urge you to play with it. And this Hello World app is so great because you can play with it. If you want to explore more about the networking options, it's a great tool to test with. In the Docker course that I'm creating, I actually use this image to learn all about the various options that we have with Docker. But let's go back and cover. Hopefully you're seeing my screen here again. All right. So today in the Docker webinar, we actually did. We just dipped our toes in, right? We didn't learn everything there is to know about Docker because I'm good, but man, I'm not that good. And basically, if you want to learn more, there's some advanced networking stuff. You can share an IP address with the host. You can bond the networks together between containers. Data. If you're running a web server, you need to have access to the data so that you can access external data. You just specify what folders that container is going to have access to. It's really easy. I mentioned you can link environments, so you can link environments together so they can communicate with each other. Even though they're running inside their own little world, you can communicate with them. This is perfect for like a web server and a MySQL server who need to communicate with each other. You can link those environments. The custom Docker file. Now at the very beginning I talked about the Docker file is how you create an image. Well, if you create a custom Docker file, you can have your own image that uses like CentOS as a base, and then you add all the stuff that you need, and it works really, really well. And then I wouldn't have the time. So if you want to use a cool GUI tool, graphical user interface, if you're not into the whole command line nerdery that we did today, you can go, and I don't know if this is Kitematic or Kitematic. You can say whichever you want and say, no, that's how Shawn Powers told me to say it. That's the right way. If you do this, you can go there. There's what it does is you can download it for Windows or OS 10. You download a single application and it will install a virtualization platform. It'll install Docker and a really cool GUI that you can control these things with. So if you're a point and click kind of person, you can learn about Docker using this. I'm going to say Kitematic. That'll be my official stance on how to say it. All right. So anyway, you go there and then you're good. So I did a good job. We have 5 minutes left for questions and answers. So if you have questions, I'm going to hand it over to Karen. I know that there are some questions there. So Karen, I'm going to give the talking stick to you. So ask me tough questions and I'll try to answer them.
Fantastic. Thank you so much, Shawn. You've done a great job here. John Whitaker actually came in with our very first question. Why not use -- name as part of the Docker run so you don't have the random name?
So that is a great question. And yes, that is a command line flag, so you can determine the name of your container. But to be honest, I like to show with as few flags as possible when I'm demonstrating. And also, on a quite honest note, the names usually make me giggle. Things like Hungry Cray or Silly Hippo or whatever the names are. I like those, and I think that names like that stick when you're teaching. But yes, if you're running it in a production environment, you do something like -- name Plex. If you're like Dockerizing the Plex application, that's a perfect way to keep track of things so they don't all have silly names.
Awesome. Very good. And Kirti, and forgive me if I'm not pronouncing your name correctly here, Kirti, but Kirti asked, we have 90% Windows and 10% Linux. Does this Docker concept work for Windows?
Yes, and I didn't mention that at first, but I probably should have. Docker runs in Windows, OS 10, or Linux. But the gotcha is, and there's a gotcha, you can only run Dockerized Windows apps on a Windows server. So you can run the Docker daemon on a Windows server, but only Windows applications can be Dockerized on that. And the same with Linux and OS 10. If you're Dockerizing a Linux application, it has to be on a Linux server. That's where it actually varies. That's a con when compared to a virtual machine, because with a virtual machine environment, you can spin up any operating system you want regardless of what the host OS is. So that's a weakness, I guess, but you can, yes, it is possible to use Docker on all the common platforms.
Awesome. And Ashish asked, what is the difference between Docker and Vagrant?
So Vagrant is another really awesome tool. But the difference is Vagrant actually automates and scripts the process for creating a virtual machine. So Vagrant is another command line tool, and it'll get things going, but it actually takes the further step of creating an entire virtualized hardware device and installing an operating system on that. And so you're actually using a VM as opposed to a container. So it's a little less efficient, if that makes any sense.
Okay. And we've got time, I think, for a couple more questions, and they just keep rolling in. Benjamin asked, why no artichokes? But I think we can skip that one. And
oh, in the picture, I'm holding artichokes. Don't you see the artichokes I'm holding in the picture?
Now I do. I didn't before, but now I do. And Jeremy asked, how are CPU memory resources handled when running multiple containers? Can you specify a certain amount of memory for each container?
Well, what happens inside Docker is that it's just an application running on your system. So while the environment is isolated and they don't see each other, the applications can't see the other applications that are running and they don't see their environments, it does share all of the memory on a thing. So if you have a runaway process, it is easy for it to kind of hog a lot of the space. There may be some options in Docker to limit that inside when you're creating the image or things like that. Honestly, I don't have the complete answer to that, other than it is just an application running on the system, so it's very much shared with other applications on your system.
Okay, and I think we have time for one last question. And John asked, how would you define the difference between Docker and Choreo's RKT?
Well, for me, my definition would be that I know what Docker is, and I don't know what CoreOS RKT is. Not ashamed to admit, I honestly, I don't know what that is. So it's possible that it's another container. Like, okay, for example, and I'm assuming that's what it is. BSD, Unix, has had containers for a long time. They call them jails or things like that. So the concept is not new. What's new is that Docker is kind of the method for taking advantage of container concepts. Linux containers even have been around a lot longer than Docker. Docker is just a really easy way to manage containers and images on your system.
All right. And that puts us right at 30 minutes. So thank you so much, everyone, for being a part of our session here today. Shawn, you are my favorite trainer. I probably shouldn't say that out loud, but thank you so much for your time. You're a rock star, and we appreciate all of the work you've been to demonstrating this for us today. Thank you, everyone, for being here, and make it a great day.
All right. Thanks, everybody. Talk to you later.